Hello, I'm Tom from TC Tiny and we're here for another burn test. Today we're building a box and throwing it in a bonfire. The purpose of this test is to see how hot the temperature of the inside of my house might get to during a severe fire. This is the inside. It's filled with a consortium of different plastics melting from timber ranges about 50 degrees up to 250 degrees. The lowest melting piece there was a piece of cheese. Here we have a second box. This replicates the interior wall construction, 15mm ply, and we're going to put our first box inside of that and fill it with insulation. This replicates my standard wall construction for a flame zone tiny house. It's 90mm thick. It's just earth wall insulation, which is fiberglass. Nothing special about that. This is the outside. We're going to put some 45mm thick pine battens on it. Again, how I build my flame zone houses. And within that 45mm cavity, we're going to jam 50mm of rock wool insulation. I don't put this everywhere in my houses, just particularly vulnerable sides, anything that might come under severe flame contact. It does an excellent job of keeping out the heat as well as not combusting. And the cladding is 12mm magnum board. It's obviously a fire retardant cladding, and also does an excellent job of insulating the timber behind it. All the joins are one glued together and then two corked shut with intumescent cork. That's expanding fire resistant cork. And the next part of this process is to pick up that crate, which weighs about 20 kilograms, put it inside the biggest bonfire I can get my hands on, and then backfill the hole. So that's wattle being burnt. It's dry. It's about a 4 metre high pile. It burnt for 50 minutes before I pulled the box out. And the radiant heat was significant. I'm standing about 15 metres back from it. The box is right in the centre. You can see it sitting right on top of the coals, which got to above 1,000 degrees. You can actually see the blue flames flickering in a few of these shots. This is the box after that night when I pulled it out. Did a bit of damage with my tools as I extracted it because the cladding had gone very soggy as a result of that fire. It really had crumbled away right at the bottom where it was sitting on the coals. Where it wasn't sitting directly on the coals, the radiant heat had barely scratched the top, and you can see that on the top of the box where it's in good nick. The sides have had that extreme radiant heat on it for a long period of time, and it's cracked the outer cladding. The inner gauze has done its function there. It's protected it from impact and held together the inner layer of that cladding. There's the top, barely any damage done to it other than a bit of charring. The screws had lost their washers, as you'd expect. They were rubber washers. Here you can see just a few gaps opening up here and there. If it had its steel corners on, as I do with a house, I think it would have been in much better condition. The timber frame still didn't ignite despite being exposed to those coals, and the reason it's not going to ignite is because of the mineral wool insulation, which you can see here on the bottom. The bottom of that crate burnt away where it was sitting on the coals for so long, and the mineral insulation became the primary defense against the flame, and it did that job superbly. Here we have the side board, which was facing the center of that fire. It was completely capitulated, but despite all that damage, the crate was largely still intact, and the inside was in excellent condition. As good as I could have hoped from this test. We'll see in a minute the charring on the timber. Obviously a big difference between the bottom corners and the top. And also the structural integrity of the timber had largely been contained. It remained very much structurally sound, the whole box. So there's the timber. The timber did an excellent job of not conducting the heat through to the interior. The mineral wool insulation did its job as both a fire defense and insulation. And the inner ply box did a fantastic job of keeping almost all the heat out of the inside. It had a few blemishes on it from smoke and from the heat, but on the inside of that ply layer there was no damage whatsoever. And for a large part, the intumescent cork had not expanded. It hadn't received the required heat to make it expand. This is a close-up of the side of that box. It's received a lot of heat, and yeah, the inside, absolutely fine. And the earth wall insulation, the fiberglass insulation, um, showed no sign of heat on it at all. No damage there. Did an excellent job. It's an R2. Did its job perfectly by keeping the heat away. In a house situation, that inner wall would be filled with services, electrical wires, and potentially gas pipes as well. So we really want to keep that inside cool, and we can see through this test that those surfaces would have been held in good condition. So here's the inside of our box. The end result was that all the plastics were intact, and notably the electrical conduit on the top right there was absolutely fine, no signs of melting whatsoever. The cheese block has of course melted, and that means our inner wall temperature there was around somewhere between 50 and 120 degrees. It is extremely important that the inside of a house stay cool during a fire, because those plastics represent things like solar batteries, inverters, electrical power points, and all your belongings too on the inside of a house, which you would certainly hope were safe within that fire, so that you had a house to return to. Also, notably, no smoke damage. So, more tests to come on this front. Hope that was certainly useful. If you want more information, check out the rest of the channel. If you've got questions, leave them below. You can find all my information at TC Tiny on Facebook, YouTube, Instagram, and the website. Thank you very much. I've been Tom from TC Tiny.